question 1, it says that in the expansion of kx plus 2 upon x to the power 4, where k is a positive constant, the term independent of x is equal to 150. We have to find the value of k and then determine the coefficient of x squared in the expansion. Now, we know when we're expanding through binomial theorem, the formula is NCR a to the power n minus r, b to the power r. Now, when it says independent of x, that means that the power of x is equals to 0. So in the first step, we know that the value of n is 4, so we can write it as 4CR. In A, we have kx, and this will become 4 minus r, b to the power r. Now, as we're trying to first find the value of k, we'll bring this x in the numerator. We can write it as 2x to the power minus 1 to the power r is equals to x to the power 0. Now, to find the value of r, that will basically give us the term independent of x. So over here, this is x to the power 4 minus r multiplied by this is x to the power minus r. And it says that the term independent of x is equals to 150. So we know that this coefficient of x to the power 0 will be 150. So first we can put it equals to 0. This will become 4 minus r equals to 0. 4 is equals to 2r. So r is equals to 2. Now, once we have the value of r as 2, now we can find the value of k. So in place of r, we can substitute 2. So this will become 4c2. Kx to the power 4 minus 2, that is 2, into 2 upon x to the power of 2. And that will be equals to 150. Now, 4c2, when we substitute this in the calculator, so 4c2 is equals to 6. So this will become 6 multiplied by k square into x square. Now x square and x square will cancel out, into 4 upon x squared is equals to 150. X square cancels out. So we have 24 k squared is equals to 150. So k squared is equals to 150 divided by 24. Now simplifying this, we'll get this as 75 upon 12. And then this will become 25 upon 4. And as it's a square, so when we square root both the sides, the value of k will come out to be 5 upon 2. Now, as k is a positive constant, so we'll just take the positive value, and k is equals to 5 by 2. Now, once we have the value of k as 5 by 2, to find the coefficient of x squared, well, we just have to first find out at which value of r will give us the term x squared. So what we can do is, we know that, again, we can repeat the same step, 4CR, a to the power. Now, in place of k, we already have 5 upon 2. So that will become 5 upon 2 to the power of x to the power 4 minus r into 2 power x minus 1 to the power r is equals to x squared. So first we'll try and find the value of r, which will make the term x squared. So this will become x to the power 4 minus r multiplied by x power minus r, and we need the power 2. So this is x2. Simplifying this, we get 4 minus r is equals to 2. So 4 minus 2r is equals to 2. We'll get 2r is equals to 2. So it means r is equals to 1. We could have done this directly as well, but we can also find the value of particular value of r through this method. Now, once we have the value of r, we can just write it as 4c1, 5 upon 2 into x to the power 4 minus 1 into 2 upon x to the power of 1 is equals to, so 4c1 is 4. This will become 5 upon 2 x cubed into 2 upon x. So this will cancel out. We'll get x square over here. So we have the term x square. This 2 and 2 will cancel out. 4 times 5 is 20. So the coefficient will become 20. In question 2, it says that the curve y equals to x square minus a upon x has a stationary point at minus 3 comma b. We have to find the value of the constants a and b. Now, stationary point means dy dx is equals to 0. So in the first step, we'll first find the dy dx. And before we find the dy dx, we should always bring the variable, if it's in the denominator, to the numerator. So this will become x square minus a x to the power minus 1. So this will become dy by dx is equals to 2x, and minus will make it a plus, ax to the power minus 2. Now, when we substitute the value of x as minus 3, dy dx will be 0. So this will become 0 is equals to 2 times minus 3 plus a into, and we can write it as a upon 3 whole squared. So this will become minus 6 plus a upon 9. So a upon 9 is equals to positive 6. A will be is equals to 54. Once we have the value of a, to find the value of b, we can just substitute the coordinates in the original equation. So the original equation is y is equals to x square minus 54 upon x. Now in place of x, we have to substitute minus 3. So when we put x equals to minus 3, this will become plus 9 minus 54 divided by, and this will become minus 3. So this will be y is equals to 9 plus 54 upon 3 is 18. Minus minus becomes a plus. So the value of b, which is basically the value of y, will be 27. So we can say that the value of b will be 27. In question 3, it says that a diagram shows a sector of a circle center O with OB, OC equals to 15. The size of angle BOC is 2 by 5 pi. Points A and D lie on the line OB and OC and are joined by an arc AD of a circle center O. The shaded area is bounded by the arcs AD and BC, and the area of the shaded region is 209 upon 5 pi. We have to find the perimeter of the shaded region, giving our answer in terms of pi. Now, to find the perimeter of the shaded region, we should know that it includes the line AD. So we can write the perimeter. So the perimeter will be is equals to the length of the line AD, AB, plus the line DC, plus the arc length AD. So we can write it as arc AD plus arc length of BC. Now, to find the length of AB, first we need to find the length of OA, and then we'll be able to find the length of AB as well. And once we have this length, we know that AB and DC will be equal. And then once we have this OA length, we can find the arc length AD as well. And then we can directly find the arc length BC using the formula S equals to R theta. Now, how to find the length OA? We know that the area of the shaded region is 209 upon 5 pi. So we know that to find the area of the shaded region, it is equals to the area of the sector. So we can write it as area of the sector BOC minus the area of the sector AOD. Now we know that this angle is 209 upon 5 pi. So the total area will be half, where the formula is half r squared theta. So we can write it as half into r squared will become 15 squared multiplied by theta is given as 2 by 5 pi. So this will become 2 upon 5 pi minus. Now let's assume that this length is x. So in any of these questions, if we have an unknown value, we should directly assume it by giving it an unknown value like x, y, or z. So we know that the area AOD will be equals to half into x squared into the angle, which is 2 upon 5 pi. And we know that this difference will be equal to the area of the shaded region, which is 209 upon 5 pi. Now, simplifying this, we know that 15 square is 225. So 225 into 2 upon 5 pi minus this will become half into x squared into 2 by 5 pi is equals to 209 pi by 5. Now we can simplify, we can cancel this 2 out over here, 5 1 times 5, 4, and this will become 45. This 2 and 2 will cancel out. So we'll get 209 pi upon 5. And we can also take pi common on the right hand side. So this will become pi into, so this will become 45 minus x squared, as 2 and 2 cancelled out. So this will become, okay, you already also have a 5 over here. So this will become x squared upon 5. Now pi and pi will cancel out. So this will become 209 upon 5 is equals to, now we can take the LCM. So 45 times 5 will be, that is 225 minus x squared upon 5. This 5 and 5 cancels out. We bring the x squared over here, subtract 209. So x squared is 16. The value of x will be equals to 4. Obviously, we'll take the positive value. Now, once we have this length, which is now the length of OA or OD, We can easily find the arc length over here for AD. So the arc length is given by the formula. So we can make some space over here. So the arc length is given by S is equals to R theta. The radius is now 4 into the angle is 2 by 5 pi. So this total length is 8 by 5 pi. And so this is the arc length AD. We can write it as arc length AD. And then the arc length of BC will be given by, so the total radius was 15. So that will become 15 multiplied by 2 by 5 pi. So we can write it as 5 times 3 is 15. So this will become 6 pi. Now we have these arc lengths and this total length was 15. So we know that AB will be 11 as this length is 4 and this is 4. So this will also be 11. So this will become 22 plus 8 upon 5 pi plus 6 pi. So we can write it over here 8 upon 5 plus 6, taking the LCM. That will become 6 5 is 30. So 38 upon 5 pi. So 22 plus 38 upon 5 pi centimeters is the perimeter of the shaded region. In question 4, it says that show that the curve with the equation x square minus 3xy minus 40 equals to 0 and the line 3x plus 5 plus k equals 0 meet for all values of the constant k. Now, whenever we have an unknown constant and we have a quadratic equation, we should know that we'll be using the discriminant b squared minus 4ac. So in the first step, what we'll do is we'll make y subject from the equation of the line. So that will become y is equals to minus k minus 3x. And we'll substitute it into this equation. So this will become x squared minus 3x into minus k minus 3x minus 40 is equals to 0. Expanding this, we'll get x squared plus 3xk plus 9x squared minus 40 is equals to 0. So x squared plus 9x squared becomes 10x squared plus 3xk minus 40 is equals to 0. Now using the discriminant b squared minus 4ac, the value of a is 10, which is the coefficient of x squared. The value of b, the coefficient of x will be 3k, and the constant will be minus 40. Substituting this into this equation, we will get 3k squared. So that is 9k squared. So we can first write it as 3k squared minus 4 into a is 10 into c is minus 40. So this will become 9k squared. 4 times 10 is 40. 40 times 40 is 1600. And this will become a plus. So this will become plus 1600. Now, as we had to show that they meet for all values of the constant k, we had to show, so this will be 9k squared. We had to show that this b squared minus 4ac should be greater than 0. Now, what we can see is that for any value, negative or positive value, when we substitute it for k over here, this will become a positive value, and when we add it, this will every single time be greater than 0. And if b squared minus 4ac is greater than 0, it means that the curve and the line are intersecting at two different points. And from this, we can observe that for all values of k, b squared minus 4ac will always be greater than 0. In question 5, it says that the equation of a curve is such that dy dx is given as 4x minus 3 root x plus 1. We have to find the x coordinate of the point on the curve at which the gradient is 11 by 2. Now we know that dy dx is basically the gradient of a curve. So we can write it as 11 upon 2 is equals to 4x minus 3 root x plus 1. Now cross multiplying, we'll get 11 is equals to 8x minus 6 root x plus 2. Bringing the 11 on this side, we'll get 8x minus 6 root x plus 2 minus 11, that's minus 9 equals to 0. Now, this is a form of a quadratic equation. We can just use a simple substitution. We can write y is equals to root x and y square will be is equals to x. As if you whole square both the sides, you'll get y square equals to x. This equation, we can write it as 8y squared minus 6y minus 9 equals to 0. Factorizing, we'll get 8y square minus 12y plus 6y minus 9 equals 0. Taking 4 common, we'll get 4y is equals to 2y minus 3 plus taking 3 common, we'll get 2y minus 3 equals to 0. So the two values of y will be y equals to minus 3 by 4 and y equals to 3 by 2. Now we know that x is equals to y squared, as we have to find the values of x. So squaring the values of y will get 9 by 16, and the second value of x will be 9 by 4. Now, if we substitute x equals to 9 by 16 into this expression, that will not be equals to 11 upon 2. So the only possible answer for which the gradient is 11, the coordinate of x will be 9 by 4. In part B, it says given that the curve passes through the point 4, 11, we have to find the equation of the curve. To find the equation of the curve, we'll have to integrate the expression for dy by dx. We can first rearrange it and write it as dy is equals to, we'll multiply dx on this side. We'll write it as 4x minus 3x to the power half plus 1 and dx. Now integrating both the sides, so integrating dy, we get y equals to 4x squared upon 2. So that will become 2x squared. This will become 3x to the power 3 by 2 divided by 3 by 2. So the 2 will come in the numerator and 3 will cancel. So we can just simply write it as 2x to the power 3 by 2. Integrating 1 will get x plus c. So now substituting the values of x and y, which is 11 and 4. So 11 is equals to 2 times, that will become 4 squared. So that will become 16 minus 2 times the value of x is 4, and 4 to the power 3 upon 2, that will be 8. As square root of 4 is 2 and 2 cube is 8, plus 4 plus c. So 11 is equals to 32 minus 16 plus 4 plus c. So 11 is equals to 16 plus 4 is 20 plus c, and the value of c will be equals to minus 9. So the final expression for the equation will be y equals to 2x squared minus 2x to the power 3 by 2 plus x minus 9. In question 6, it says that circle C1 and C2 have the given equations, and we have to find the distance between the centers of the circles. Now for the circle C2, we know that the center is 9, comma minus 4. So the center is given as 9, comma minus 4. For the circle C1, first we'll have to find the center. We can rearrange the equation and write it as x squared plus y squared plus 2 times 3 times x minus 2 times 5 times y plus 18 equals to 0. So the equation, the coordinates for the center in this case for circle C1 will be, so this is minus 3 and this will be positive 5. So we have the centers for the two circles, which are minus 3, comma 5 and 9, comma minus 4. Once we have these two coordinates, we can just apply the distance formula, which is x2 minus x1 whole squared. So x2 will be 9 minus minus 3. So that will become 9 minus minus 3 whole squared plus minus 4 minus 5 whole squared. This will become 12 squared, which is 144 plus 9 squared, that is 81 square root. 144 plus 81 is 225, and the square root of 225 is 15. So the distance between the two, the centers of the circles is 15. Now in part B, it says that points P and Q are points on C1 and C2 respectively, and the distance between P and Q is D. So we have to find the greatest and the least possible values of D. Now to find the greatest and the least possible value, we can first make the circle. So let's say this is circle C1 and this is circle C2. Now what we know from part A is that the distance between these 2 points is given as 15. Now to find the least distance, well, first let's make this line. We know that this distance is 15. We need to find the radius of each of these two circles. So for C1 and C2, if we can find this length, the radius of C1 and the radius of C2, we know that these 2 points will be the closest. So this will be the least distance, and these 2 points on the furthest ends will have the largest distance. Now, how to find the radius? Well, we can use the general equation of a circle, and it was for circle C1, it was x squared plus y squared. We already had the center, which was minus 3 comma 5. So this was plus 6x minus 10y plus 18 is equal to 0. Now what we know is that a squared plus b squared minus r squared will be equals to this value is equals to 18. And just for a quick revision, as the general equation is given by x minus a whole squared plus y minus b whole squared is equals to r squared. Expanding this, we get x squared minus 2ax plus a squared plus y squared minus 2by plus y squared is equals to r squared. And then if we simplify this, the constant terms are a squared and this should be b squared. So this will be a squared plus b squared. Bringing the r squared on this side, this will make it minus r squared equals to 0. So this is what the constant term is equals to. So a squared plus b squared minus r squared is equals to 18. We know the value of a and b, the coordinates of the center is minus 3 comma 5. So 3 squared is 9 plus 5 squared is 25 minus r squared equals to 18. R squared will be 34 minus 18, which is 6. So r will be equals to 4. So the radius of this circle is 4. For C2, if we bring the 64 on that side, so this will become positive 64. And then as it is equals to r squared, so the radius will become equals to 8. As r squared will be equals to 64, the radius will be 8. Now this total distance is 15 and then 15 minus 8. So for the smallest distance or the least possible value of d, that will become 15 minus 4 minus 8. And for the greatest possible value of d, so we will add, this will be 8 and this will be 4. So that will become 15 plus 4 plus 8. So this will be 15 minus 4 is 11 minus 8, that is 3. And then 15, that will be equals to 27. So these are the two possible least and greatest values. In question 7, the diagram shows part of the curve with the equation y equals to 12 upon cube root 2x plus 1. The point A on the curve has coordinates 7 upon 2 comma 6. We have to find the equation of the tangent to the curve at A. Now to find the equation of the tangent, first we'll have to find the gradient at the tangent, which is given by dy by dx. So before we find the dy dx, we'll first bring the denominator into the numerator. So that will become 12 into 2x plus 1 to the power of minus 3. Now, differentiating, we'll get dy by dx is equals to minus 3 times 12 is minus 36 into 2x plus 1. We'll decrease the power by 1, so that will become minus 4. And the derivative of 2x plus 1 is 2. So that will become minus 72 upon 2x plus 1 to the power of 4. Now the value of x is given as 7 by 2. So we can write it as minus 72. 2 into 7 by 2 will become 7. 7 plus 1 is 8. So that will become 8 to the power of 4. Now, so 8 to the power of 4, that is equals to 4096. And then minus 72 divided by, so minus 72 divided by 4096, that's equals to minus 9 by 512. So that is the gradient over here. And once we have the gradient, now we can find the equation. Okay, so cube root, there is a small mistake. The cube root is not as minus 3. It's not cube. This should have been minus 1 upon 3. So a slight change in this, we'll get minus 1 by 3 into 12, that's minus 4 into 12x, 2x plus 1, minus 1 upon 3 minus 1. So that will become minus 4 by 3. So this will become minus 4 by 3 and then multiplied by 2. So now we get minus 8 upon 2x plus 1 to the power of 4 by 3. Now substituting x equals to 7 by 2. So 2 into 7 by 2, that's 7. 7 plus 1 is 8. So we'll get minus 8 upon 8 to the power 4 by 3. So cube root of 8 is 2 and 2 to the power 4 is 16. So that will become minus 8 upon 16, which is equals to minus 1 by 2. Now once we have the gradient, we can find the equation. So the equation expression is y minus y1 equals to m into x minus x1 So it will become y minus 6 is equals to minus 1 by 2 into x minus 7 by 2. Simplifying, we'll get y is equals to minus half x plus 7 by 4 plus 6. Simplifying, we'll take the LCM, we'll get minus 1 by 2x plus 6 4 times is 28. So that will become, say, 24 plus 7, that will become 31 upon 4. So that's the equation of the tangent. In part B, it says find the area of the region bounded by the curve and the lines x equals to 0, 7 upon 2, and y equals to 0. So we have to find this area. We can integrate this expression and then put in the limit 7 by 2 or 0, or we can also take this value, this y value is 6. So we can, but in this case, we'll have to make x a subject. So we can just simply use this expression and integrate it. So to find the area, we'll have to integrate the expression. So this is 12 into 2x plus 1 to the power of minus 1 by 3. We'll integrate it and put in the limit 7 by 2 and 0. So when we integrate, we first increase the power by 1. So minus 1 upon 3 plus 1. So that will become 2 by 3. We will divide in the denominator by 2 by 3 and we'll multiply it with the derivative of 2x plus 1. So that will become 4 upon 3. This 3 will go into the numerator. That will make it 36 upon 4 into 2x plus 1 to the power of 2 by 3. Simplifying, we can write it as 9 into 2x plus 1 to the power of 2 by 3. Now substituting the limits 7 by 2 and 0. Now when we put in 7 by 2, so this will become 9 into, we know that 2 into 7 by 2 is 7 plus 1, 8. So 8 to the power 2 by 3. And then when we put it, so this is for the limit 7 by 2. And then when we put in the limit x equals to 0, so this will become 9 into 1 to the power 3 by 2, which is 9. So 9 to 8 to the power 3 by 2 is 4. So this will become 9 times 4, that is 36 minus 9. So the area of the shaded region will be equals to 27 square units. In question 8, it says that it's given that beta is an angle between 90 and 180, such that sine beta equals to A. We have to express tan square minus 3 sine cos in terms of A. Now, in the first step, we'll have to first make the angle beta between 90 and 180, which is the second quadrant. So let's say this angle is beta. And as sine beta is 1, we know that sine is opposite over hypotenuse. So that will become A upon 1. Applying Pythagoras theorem, so this length will become 1 minus A squared. So for tan squared, we can write it as A upon opposite over adjacent. So A upon 1 minus A squared, and this will become whole squared minus 3 sine beta. So sine is A and cos beta will be adjacent over hypotenuse. So that will become square root of 1 minus A squared. So simplifying, this will become A squared upon 1 minus A squared minus 3A into square root of 1 minus A squared. So this will be the expression for tan square minus 3 sine cos in terms of A. In part B, it says solve the equation sine square plus 2 cos square equals to 4 sine plus 3. As we have the expression in terms of sine and we have cos square over here, so we can, in place of cos square, we can write 1 minus sine squared equals to 4 sine plus 3. Simplifying, we get sine square plus 2 minus 2 sine squared equals to 4 sine plus 3 minus sine squared plus 2 is equals to 4 sine plus 3. Simplifying, we'll get sine squared plus 4 sine, and then 3 minus 2 will become minus 1. So this will become minus 1 equals to 0. Now we have to first solve this quadratically, or we can use the quadratic formula. So this will become x is equals to, and we'll just make sure that there is no arithmetic mistake over here. So this is 2 times 1 minus sine squared, that's fine. This will become plus sine squared over here. This is 4 sine, and then this is 2, so 3 minus 2 is, so this is a plus 1 over here. Now applying the quadratic formula, we'll get minus 4 plus minus. So this will become b squared, which is 16 minus 4ac. So 1 into 1 divided by 2 times a, which is 1. So sine theta will be is equals to minus 4 plus minus square root of 12 upon 2. Substituting these values in the calculator, we'll get minus 4 plus root 12, that is minus 0.535 divided by 2. So we'll get minus 0.267 and minus 4 minus root 12. And as this value is greater than, so minus 4 minus root 12 upon 2 is greater than 0. So we'll ignore this value. Now taking sine inverse of 0.267, we'll get 15.48. Now as it is a negative sign, so we'll make this in the negative coordinates of sine. So we'll write it as A, C, T, and S over here. The basic angle when we do sine inverse of 0.267, we get the basic angle by just putting the positive value over here. And this basic value is 15.48. We'll make it in the third quadrant, 15.485, or we can write it as 15.49. And we'll make 15.49 over here as well. Now finding the value of theta. So the first value will be 180 plus 15.49. So this was 15.49. So theta will be 180 plus 15.49. And the other value of theta will be 360 minus 15.49. The final answer will be 195.49. And 360 minus 15.49, that's equals to 344.51. As we have to give our answer to one decimal place in terms of angles, so this will become a 95.5 and 344.5. In question number 9, it says that the equation of a curve is y equals to 4 plus 5x plus 6x square minus 3x cube. We have to find the set of values of x for which y decreases as x increases. Now, what we have to understand about this is that, let's say if we make a curve like this over here, up till this point, so as the graph is decreasing, as the value of x is increasing, we can see that the value of y is decreasing. Or even if we make the curve this way around, for this part, let's say this is point A, O, and this is A, and let's say this was A over here. From O to A, as x is increasing, y is decreasing. It means that the gradient for this part is negative. So we can write dy dx as less than 0. So we now know that for this case, dy dx must be less than 0. First, we'll find the expression for dy dx. So dy dx will be is equals to, this will become 5 plus 12x minus 9x squared. Now, solving this quadratically, so this will become, and this is in place of dy dx, we can write this as 5 plus 12x minus 9x squared is less than 0. Factorizing this equation, this is 9x squared plus 12x plus 5 as less than 0. We can apply middle term breaking as well. So this will become plus 15x minus 3x plus 5 as less than 0. Taking minus 3x common, this will become 3x and plus 5. Oh, this is a minus, so this will be 3x minus 5. So this will become 3x minus 5. Taking 1 common, we'll get 3x minus 5 as less than 0. So minus 3x minus 1 and 3x minus 5, these are the two values of x. So the two values of x are x equals to negative 1 by 3 and x equals to 5 by 3. Now, as this was negative value, we'll make a quadratic curve. The two values of x that we're getting, the positive value is 5 by 3 and the negative value is minus 1 by 3. Now, as the curve has to be less than 0, for this part, basically, the curve is less than 0. So the values of x will be, x should be less than minus 1 by 3 and x must be greater than 5 by 3. As we go towards the left from minus 1 by 3, this expression will be less than 0. And as we move to the right from 5 by 3, the expression will be less than 0. In part B, it says that it is given that y equals to 9x plus k is a tangent to the curve. Find the value of the constant k. Now, just from the equation, we can see that this has the gradient, this tangent has a gradient 9. And as it is a tangent, it means it will be equals to the dy dx. We know that the expression for dy dx was 5 plus 12x minus 9x square. So this is dy by dx. And we can put it equals to the gradient, which is equals to 9. Simplifying, we'll get minus 9x squared plus 12x. This is 5 minus 9, so that will make it minus 4. Simplifying, we'll get 9x squared plus 6x plus 6x. We can solve this part directly through a calculator as well. So first taking minus 3x common here, we'll get 3x minus 2 plus taking 2 common, we'll get 3x minus 2 equals to 0. So this will become minus 3x plus 2 and 3x minus 2 equals to 0. The two values of x will become, so this will become minus 2 upon minus 3. So that will become 2 upon 3 and x equals to, well, both of the values are coming out exactly the same. Now, once we have the value of x, as we have to find the value of k, if we had the value of y over here, we'll be able to find the value of k, right? So we can substitute this value of x in the original equation of the curve to find the y coordinate. So x is 2 by 3. And the equation was y is equals to 4 plus 5x plus 6x squared minus 3x cubed plus 6x squared minus 3x cubed. Substituting the value of x over here, we get 4 plus 5 into 2 by 3 plus 6 into 2 by 3 whole squared minus 3 into 2 by 3 whole cube. So the y value will become 4 plus 10 upon 3 plus this will become 4 upon 9 minus 3 into 4 upon, okay, this was a cube over here, so this will become 8 upon 27. Simplifying, this will become 3 1 times, 3 9 times, 3 2 times, 3 3 times. So 4 plus 10 upon 3 plus 8 upon, this will become 3 minus 8 upon 9. 10 plus 8 is 18, 18 upon 3 is 6. So 4 plus 6 is 10, 10 minus 8 upon 9, 90 minus 8, that is 82 upon 9. Now, once we have the y value, we can substitute it into the equation to get the x value. So the y value is 82 upon 9 is equals to, the equation is 9x. So 9 into x is 2 by 3 plus k. So this is 3 1 times, 3 2 times. This will become 6. So 82 upon 9 minus 6 will be equals to k. 82 minus 54, that is 32 upon 9. So the value of k will be equals to 32 upon 9. Just one small correction over here. This is 82 minus 54. So 82 minus 54, that is 28. So the final answer is 28 upon 9. In question 10, it says an arithmetic progression has the first term 5 and common difference d. The second, fifth, and 11th terms of the arithmetic progression in order are the first three terms of a geometric progression. We have to find the value of d. Now, an arithmetic progression is given by the formula nth term is given by a plus n minus 1 times d. So for the second term, that will become a plus 2 minus 1. So that will become a plus d. The fifth term will become 5 minus 1. So that will be a plus 4d. And the 11th term will be a plus 11 minus 1. So that will be a plus 10d. We have the value of a, that is 5. So this will become 5 plus d, 5 plus 4d, and then 5 plus 10d. Now, as they are the first, second, and third term of a geometric progression, so this is the first, second, and the third term. And we know that if we divide the second term by the first term, For a GP, it gives us a common ratio, and similarly, if we divide the third and the second term. So we can say that 5 plus 4D divided by 5 plus D will be equals to 5 plus 10D divided by 5 plus 4D. Cross multiplying, so that will become 5 plus 4D whole squared. Expanding, that will become 25 plus, so that 40D plus 4D whole squared will become 16D squared. 5 times 5 is 25 plus 50D plus D times 5 is 5D plus 10D squared. Simplifying the expression, we'll get 6D squared, 40D minus 50D, 55D, that will become minus 15D, and 25 and 25 will cancel out, so that will be equals to 0. Taking 3D common, so this will become 2D minus 5 equals to 0. So one of the values of D is 0, and the other value of D is 5 by 2. Now, as the value of D has to be greater than 0, so D will be equals to 5 by 2. In part B, the sum of the first 77 terms of the arithmetic progression is denoted by S77. We have to find the difference of 77 terms of the AP and 10 terms of the GP. Now, to find the sum of 77 terms, we know the formula is 2a n upon 2 into 2a plus n minus 1 times d. So n is 77, so this will become 77 upon 2 into 2 is 5 plus n minus 1, so that is 76 into 2.5. Substituting these values in the calculator, so 76 into 2.5, that is 190 plus 10, that will become 200 into 77 upon 2. So that will become 7700. And now to find the sum of the first 10 terms of the geometric progression, the sum of a geometric progression is given by a into 1 minus r to the power n upon 1 minus r, or in our case, as the value of r is greater than 1. So we know that these are the first, second, and third terms. In place of d, when we put 2.5, so this will be 7.5. 4 times 2.5 is 10, and 10 plus 5 is 15. And then 10 into 2.5 is 25 plus 5, that is 30. So 30 upon 15 is 2, and 15 by upon 7.5 is 2. We know the common ratio is 2, and the first term is 7.5. So the sum formula will become 7.5 into, and the value of r is greater than 1. So we can first rearrange it and write it as r to the power n upon r minus 1. This will be 7.5 into 2 to the power 10 minus 1 divided by 2 minus 1, which is 1. Substituting this in the calculator, 2 to the power 10 minus 1 multiplied by 7.5. This is equals to 7672.5, 7700 minus the answer. So the difference will be 27.5. In question 11, it says that the function is defined by f of x is equals to 3 plus 6x minus 2x squared. We have to express f of x in the form a minus b into x minus c whole squared, and then state the range of f. To express f of x in this form, we can first, we can do it by completing the square method, or we can do it by the comparison method. So if we just simply expand this expression, this will become x squared minus 2xc plus c squared. Opening up the bracket, we'll get a minus bx squared plus 2xc minus bc squared is equals to 3 plus 6x minus 2x squared. Now comparing the coefficients, the coefficient of x squared over here is minus b, and on the right hand side it is minus 2. So the value of b will be is equals to 2. The constant term is a and minus bc squared. So a minus bc squared will be equals to the constant term over here, which is 3. And the coefficient of x over here is 2c, and okay, so this would have been 2bxc. So this is 2bxc. So 2bc is a coefficient of x, and that is equals to 6. So we have the value of b, which is 2. 2 times 2 is 4. So 4c is equals to 6. So c will be is equals to 3 upon 2. Once we have the value of c as 3 upon 2, we can substitute it over here to find the value of a. So a minus 2 into 3 upon 2 whole square, that will become 9 upon 4 equals to 3. So a is equals to 3 plus 9 upon 2. Simplifying this, we'll get 2 plus 3 is 6. So that will become 15 upon 2. Substituting this over here, we'll get the value. So a is 15 upon 2. So this will become 15 upon 2 minus 2 into x minus 3 upon 2 whole squared. And now as we have to also state the range of the function and it is an element of real numbers, we know it as it is a negative sign over here, it will have a maximum point. And the turning points in this case are, so the x value is 3 upon 2 comma 15 upon 2. The range of f in this case will become, as it is the highest point is 15 upon 2. So f of x, we can write it over here, f of x will be less than equals to 15 upon 2. In part B, it says the graph of y equals to f of x is transformed to the graph of h of x by reflection in one of the x's followed by translation. Now we already know that the turning points for f of x are at 1.5, 3 upon 2 is 1.5 and 7.5. So this is the general graph. It is first reflected in one of the x's and then translated, and the final function has a minimum point. Minimum point means this graph has been inverted. It means it has been reflected in the x-axis. So in the first step, we'll reflect it in the x-axis. So this point 1.5, this will become 1.5 comma minus 7.5. The graph will become like this in the first step, and these coordinates will be 1.5 comma minus 7.5. As at this point, the value was positive 7.5. Now the minimum point is at the origin and we have to translate it. So we have to move it 1.5 units back. So first we'll write the reflection is in the x-axis. And then we have a translation. In the x direction, it is minus 1.5. And in the y direction, we have to move it 7.5 units upwards. So that will be 7.5. In part C, it says that the function g is defined by 3 plus 6x minus 2x squared for x less than equals to 0. We have to sketch the graph of g of x and explain why g is a one-to-one function. Now, this g of x is exactly the same as the f of x function, and the turning point is at 1.5 and minus 7.5. However, as it is only x is less than equals to 0, so we'll just make this part over here. And to explain why it is a one-to-one function, it means that for every value of y, we have only one value of x. So we can just write for every y value, there is only one x value, which makes it a one-to-one function. In part D, it says sketch the graph of y equals to g inverse of x. Now, the inverse function is basically a reflection of the same graph in the line y equals to x. So in the first step, we'll make the line y equals to x. Okay, so let's say this is passing through the origin. So let's say this is the origin. This is the function g of x. And then to make the graph, so this point will be reflected over here. We can use a different color over here. And once we reflect it over here, this graph will be like this. So this will be the graph of g inverse of x. We also have to find the expression. Now to find the expression, we have to always use the complete square form. The complete square form is 15 upon 2 minus 2 into x minus 3 by 2 whole squared. So this is g of x. To find g inverse, first we'll write y over here. So this will become 15 upon 2 minus 2 into x minus 3 by 2 whole squared. Now changing the values of x and y, we'll get x equals to 15 upon 2 minus 2 into y minus 3 upon 2 whole squared. We have to make y the subject, so we can write it as 2 into y minus 3 by 2 whole squared. We take it on the left hand side and we write it as 15 upon 2 minus x. Now we bring the 2 on this side, so this will become y minus 3 upon 2 whole squared is equals to 15 upon 4 minus 1 upon 2x. And then we take the square root on both the sides. So this will become square root of 15 upon 4 minus 1 upon 2x. And then finally, y will be is equals to, we'll take minus 3 by 2 on this side. So this will become 3 upon 2. And with the square root, we have both plus minus signs over here. And just one small, okay, so this is fine over here. So 3 upon 2 plus minus square root of 15 upon 4 minus half x. Now we also have to decide which of these values do we have to take, 3 upon 2 plus or the minus sign. Now, if we take the positive sign over here, so the value of y will become 3 upon 2 plus and 15 upon 4, and it will exceed this value over here. So let's say if we so if we take the positive value over here, we know from the function that the y value or the inverse function has a range which is always lesser than, the y values will always be less than 0. So if we take a positive value over here, this will make it a positive, and that's not possible. So we'll have to take only the negative value, which is 3 upon 2 minus square root of 15 upon 2 minus 1 upon 2x. And from the graph, we can also observe that for the inverse function, it is always lesser than 0. So we should always have a negative sign over here.